In this lesson, we're going to talk about how to simplify algebraic expressions, particularly those that contain irrational exponents. Now, if you want to pause the video and you want to try these two examples, feel free. But before we do that, let's go over some properties of exponents. When you multiply two terms that have the same base, the base being x, you can add the exponents. So this is equal to x raised to the 2 plus 3, or x to the 5th power. And to see why that's the case, x squared means that you're multiplying two x variables together. X cubed is equivalent to multiplying three x variables together. In total, you have 5 x variables being multiplied, so we get x to the 5th power. So when you multiply terms with the same bases, you can add the exponents. Now when you're dividing, if the base is the same, you can subtract the exponents. So this is 5 minus 2, which is 3. And you could see it this way. X to the 5th power means that you're multiplying 5 x variables together. X squared is just x times x. You could cancel 2 of the x variables on the top and the bottom of the fraction, and that leaves you with 3 x variables left over, which is x to the 3rd. Now what about this? What happens when you raise one exponent to another? What's x squared raised to the 3rd power? When you raise one exponent to another, you need to multiply the two exponents. So this is 2 times 3, which is x to the 6th power. Another way to see this 3 means that you have 3 x squareds. And each x squared term is basically x times x. So notice that we have 6 x variables being multiplied to each other, which is x to the 6th power. Now, what is the difference between this expression and this one? What would you say is the difference? So here, notice that the 3 applies to the x squared term. So that tells us that we have 3 x squared. And we're basically adding 2 3 times, which is 2 times 3, or 6. Now in this case, the 3 doesn't apply to the x squared. It only applies to the 2. 2 to the 3rd power is 2 times 2 times 2, which is 8. So this is x to the 8, not x to the 6. So notice the difference. When you have parentheses, the 3 applies to everything inside the parentheses. If we don't have parentheses around the x squared, the 3 only applies to the 2. Because that's going to be important when solving this particular problem. Now before we do this, what is the answer for this one? What's 2 to the 3rd raised to the 4th power versus 2 to the 3rd to the 4th, written like that? In this case, we need to multiply 3 and 4. 3 times 4 is 12, so we get 2 to the 12th. Now for this one, the 4 only applies to the 3. So we're raising 3 to the 4th power. So we're multiplying 3 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is 2 to the 81. Notice that the results are significantly different. So we're going to apply that to this problem. So here, notice that the 2 applies to everything inside. So we're raising one exponent to another. Therefore, we need to multiply these two. So this becomes 7, and then 2 times radical 2 is just 2 radical 2. Now, something that we can do here is we can go back to this form. So for instance, let's say we have a squared raised to the third power. You can switch to 3 and 2. So you can write it as a cubed to the second power, because 2 times 3 and 3 times 2, they both multiply to 6. So what I'm going to do here is I'm going to convert it into this format. You can just basically swap these two because they both multiply to 2 radical 2. So now we have 7 squared. 7 squared is 7 times 7, which is 49. And so this is going to be our final answer. 49 square root 2. Now what about this one? Notice that the 2 does not apply to the 7. The 2 only applies to the square root of 2. And what is the square root of 2 squared? This means that we're multiplying 2 square root 2's. 2 times 2 is 4, and the square root of 4 is 2. So this part here, this entire exponent, simplifies to 2. So we get 7 squared, which is 49. So we have 2 different answers for these 2 problems. Now, let's move on to the next 2 examples. What's 5 raised to the square root of 2 raised to the square root of 2? In this case, the square root of 2 applies to everything inside. In that case, we can multiply these 2 exponents. So this becomes 5 square root 2 times square root 2. Square root 2 times square root 2 is square root 4, and the square root of 4 is 2. 5 squared is 5 times 5, which is 25. So that's the answer for that example. Now what about the next one? What's 9 square root 3 times 9 square root 3? Notice that the bases are the same, which means we could add the exponents. This is like multiplying x squared times x cubed, which is x to the 2 plus 3. So this is 9 square root 3 plus square root 3. This is 1 square root 3 plus 1 square root 3. 1 plus 1 is 2, so we get 2 square root 3. Now we could separate these 2 numbers, which are multiplied, like this. We can write it as 9 squared raised to the third. So keep in mind, if you have a raised to the 3 times 4, you can break it up to a cubed to the 4th power, or you can say a to the 4th raised to the 3rd power. In all cases, it's equal to a to the 12th. Now, 9 squared is 81. So we get 81 square root 3. An important property to keep in mind is that when the exponents are the same, you could multiply the bases while keeping the exponents the same. So we could have gotten the final answer by multiplying 9 times 9, which is 81. And then the exponent will remain square root 3. Go ahead and try these 2 problems. So in this case, notice that the exponents are the same. So we could just multiply the bases. 7 times 7 is 49. So this is 49 square root 3. Here, once again, the exponents are the same, even though the bases are different, but that's okay. So this is going to be 5 times 4, which is 20. So we get 20 square root 3. Go ahead and try this one. 8 square root 3 raised to the 2nd power. And you could try this as well. 5 square root 2 raised to the square root 3. And finally, 5 square root 7 times 5 square root 3. So feel free to pause the video and try those examples. So for the first one, we're raising one exponent to another. We can multiply the two exponents. So this becomes 8 raised to the 2 times the square root of 3. Or we could just reverse them and write it this way. 8 squared raised to the square root 3. 8 squared, which is 8 times 8, that's 64. So the final answer for this one is 64 square root 3. Now for the next one, we have an exponent raised to another exponent, so we can multiply them together. So this is 5 square root 2 times square root 3. Because these square roots have the same index number, which is an invisible 2, we can multiply what's inside of the square root. So that's 2 times 3, which is 6. So our final answer for that one is 5 square root 6. Now for the next one, we have the same bases but different exponents. So all we can do is just add the exponents. So it's simply 5 raised to the square root 7 plus square root 3. And we can't simplify this any further, so we're just going to have to leave our answer like this. Now what would you do if you saw a problem that looked like that? How would you solve it? Now if you remember, a squared times a to the third is basically a to the fifth power. But imagine going backwards. A to the fifth, which we know it's a to the 3 plus 2, we could break this up to a cubed times a squared. That's what we want to do here. So we're going to convert the addition of exponents, which is what we have here, to the multiplication of two numbers with the same base. So we can write this as 5 to the third times 5 to the square root of 7, which is what we just did here. We basically split it into two parts through multiplication. Now we could do the same for the bottom. So we can write that as 5 to the first power times 5 raised to the square root 7. Now these two we could cancel. When you divide two things that are the same, you get 1. So now we're left with 5 to the third power over 5 to the first power. And when you divide, if the bases are the same, you could subtract the exponents. So it's 3 minus 1, which is 2. 5 squared, or 5 times 5, that's 25. So that's going to be our answer for that one. Now let's work on a similar example. Let's say we have 3 square root 5 plus 2 over 3 square root 5 minus 2. Go ahead and try this example. So this one is very similar to the last one. First, let's convert the sum of two exponents into the multiplication of two numbers with those exponents. So this is 3 square root 5 times 3 to the second power. And beneath that, we have 3 square root 5 times 3 to the negative 2. So just like before, we could cancel these two because they're the same. And then we'll be left with 3 squared over 3 to the negative 2, which we could subtract the top exponent, 2, minus the bottom exponent, negative 2. So these two negative signs, two negatives will make a positive, so this becomes 2 plus 2, which is 4. And 3 to the fourth power. That's 3 times 3 times 3 times 3. These two 3's equal 9, and the other two 3's equal 9, which is 81. We could also write it as 3 squared raised to the second power, because 2 times 2 is 4. 3 squared is 9, 9 squared is 81. So that's the answer for that one. Now let's move on to our next example. 7 square root 5 plus 2 divided by 49. How can we simplify this one? Just like before, we have the sum of two exponents, so we could expand it through multiplication. So this is 7 square root 5 times 7 squared over 49. Now, 7 squared, which is 7 times 7, that's 49. And notice that we could cancel the two 49s. So our answer is going to be 7 square root 5. Here's a similar problem that you could try. Let's say if we have 2 square root 13 plus 3 divided by 8. Go ahead and take a minute, pause the video, try that problem. So let's expand the term on top. So this is 2 square root 13 times 2 to the third power divided by 8. And 2 to the third, that's 2 times 2 times 2. You're multiplying 3 2's, which is 8. So now we could cancel the 8's, and that's just going to give us 2 square root 13. How can we simplify this one? What is 7 raised to the 1 over square root 2? What is that? Before we go into that, let's talk about fractional exponents or rational exponents. X to the 1/2 is the square root of x. What it really equals is there's an x to the first power inside the radical with a 2 as the index number. X to the 1/3 is the cube root of x. X to the 3/4 is basically the fourth root of x cubed. So how can we use that to get this? Well, instead of x, let's use 7. 7 to the 1/2 is the square root of 7. We have a 1 here and a 2 here. 7 to the 1/3 is the cube root of 7 to the first power. So what is 7 over 1? 7 raised to the 1 over square root 2. Well, this 1 is going to be this exponent here. I'm going to color code it. And whatever is on the bottom should be the index number. So in that case, that's going to be the square root of 2, which I'll put it right here. So what this is equal to is the square root of 2 as the index number of the square root of 7. It looks kind of weird, but that's what it is. Now, what if we have a negative sign? 7 raised to the negative 1/2, what is that? Well, x to the negative 3 is 1 over x cubed. When you have a negative exponent, to make it positive, you need to flip it over 1. So this is going to be 1 over the square root of 7. So having this negative exponent means that we're going to have the same answer, just it's going to be under 1. So this is going to be 1 over the square root of 7 with an index number of a square root of 2. So that's all we have to do for this one. It's just making sense of it. So hopefully these examples help you to see why this is the answer, or at least how to get to it. Now let's move on. What's 7 raised to the 2 square root 5 times 49 raised to the negative square root 5? Right now the bases are different. But notice what we have here. We can write this as 7 squared raised to the square root of 5. And 7 squared is 49. So we have 49 square root 5 times 49 square root negative square root 5. Now that the bases are the same, we can add the exponents. So that's square root 5 plus negative square root 5, which adds up to 0. And anything to the 0 power is 1. So our final answer for this problem is 1. Let's work on a similar problem. 5 to the third times square root 7. and this is multiplied to 125 raised to the negative square root 7. So first I'm going to write it as 5 cubed raised to the the square root 7. 5 to the third power, that's 5 times 5 times 5, which is 125. Now that the bases are the same, we can add the exponents. Square root 7 plus negative square root 7 is 0, and this is going to end up being 1. Alright, here's a boss level challenge problem. What is the square root of 27 raised to the square root of 3 over the square root of 3 raised to the square root of 27? Feel free to take a minute and work on that example. You could use a calculator and get the answer, but let's try to simplify it. So 27, we can write that as 9 times 3. And the same is true for the other 27. We can write it as 9 times 3. Now, we can split this square root into two parts. So we could say it's the square root of 9 times the square root of 3, but it's all affected by the exponent. And we could do the same thing for the other one. Now, the square root of 9 is 3. So we have this right now on top. And we can convert this to a 3 as well. So we have this at this moment. Now, what do you think we should do here? Here's a question for you. Let's say if you have a squared times b to the third raised to the fourth. You have two different bases, each with their respective exponents. What you can do is since this exponent is raised to that exponent, you can multiply them. But we can multiply it to the 4. Multiply the 4 to each exponent. So this becomes 2 times 4, which is 8, 3 times 4, which is 12. So here we have an exponent, and we could multiply the square root of 3 to each exponent that we have there. So we have 3 square root 3 times square root 3 square root 3. Now what can we do with the stuff on the bottom? What I'm going to do is I'm going to write it like this. The square root of 3 raised to the square root of 3 raised to the third power. Keep in mind, when you raise one exponent to another, you multiply them. So this is, multiplying these two will give us just 3 square root 3. The reason why I decided to write it that way is because notice that these are similar. I want to try to cancel it. Now this 3 tells me that I have 3 of these things that are inside the parentheses. So I have 3 of square root 3 raised to the 3. So I'm going to expand it. That's what this 3 tells me. I have 3 of what's inside. Now I can cancel one of them. So now what I have is 3 square root 3. And notice that I have 2 of these left over. So I can write that as the square root of 3 raised to the square root of 3. Because I have 2 of them, it's now squared. So now what can we do at this point? What I'm going to do is I'm going to reverse these 2 exponents, because they still multiply to 2 square root 3. So this becomes 3 squared raised to the third. The cube root of 3. The square root of 3, actually. Now, wait. Let me take that back. This should be square root 3, which is what we have here. And then I'm going to raise that to the second power. There's a lot of 3's here, just so you know. There's 3's everywhere. It's easy to confuse this. Okay, but we have to keep this the same. So all we did was we would just reverse the 2 and the square root of 3 in the exponent position. The reason why we want to do that is because the square root of 3 squared, which is square root of 3 times the square root of 3, 3 times 3 is 9, this becomes 3. So we can convert everything on the inside to a 3. Now notice that these are exactly the same. When we divide them, any number divided by itself will be 1. So that is our answer. Now let's work on a similar problem. What is the square root of 32 raised to the square root of 2 over the square root of 2 raised to the square root of 32? So feel free to take a minute if you want to work on this problem. Go ahead and pause the video if you want to. So let's begin. 32, I'm going to break that into 16 and 2. And this is all raised to the square root of 2. And on the bottom, I'm going to do the same thing. Square root 2 raised to the square root 16 times square root 2. So the square root of 16 is 4. So we now have this. And on the bottom, it's also 4. Now, what should we do at this point? Now, what I like to do is distribute the square root of 2 to each exponent, just like we did before. So we have 4 square root 2 times square root 2 square root 2. Now, what should we do on the bottom? Notice that we have this, something that should be canceled. And we have this here. So what I like to do is write it this way. Square root 2, and write in this exponent first. And then the other exponent, the 4, I'm going to write it later. So that these two, they match. Now, notice that this is raised to the 1, this is raised to the 4. So I have one of these on top, 4 on the bottom. If I cancel one of each, I'm going to have 3 left over on the bottom. So this is 4 square root 2. And now I have square root 2 raised to the square root 2. I had 4, but I lost 1. So now I have 3. So now what should we do next? So right now I'm going to leave the numerator exactly the same, 4 square root 2. But I'm going to split this into 2 parts. So we have 3 of them. I'm going to split 3 into 1 and 2. So this is square root 2 raised to the first power, and square root 2 raised to the square root 2 to the second power. So I still have a total of 3 on the bottom. Now you might be wondering, why am I doing this? The reason is I need this 2 here. Yeah, these are the hard problems of rational exponents. I'm going to switch the 2 and the square root 2. So this is square root 2 squared and then square root 2. Now the square root of 2 squared, that's the square root of 2 times the square root of 2. 2 times 2 is 4, which is 2. That's how I want this 2 here, because I can get rid of that square root symbol. So this part here simplifies to just 2. Now, if you look at these two things, notice that they have the same exponents. Therefore, we can divide the bases directly. 4 divided by 2 is 2, and the exponent will be the same, and that 2 is going to go on top. Now, we also have this on the bottom. It looked like they're going to cancel, but they're not, because this is 2, this is square root 2. Notice though, we have the same exponent. So let's talk about another technique that we have that we can use here. Let's say if we have 5 to the 4 over 3 to the 4. The bases are different, but the exponents are the same. What we can do is write this as 5 over 3 raised to the 4th power, because they have the same exponents. And that's what we want to do here. Because these two are the same, we want to expand out and write it like this: 2 over square root of 2 raised to the square root of 2. Now what I'm going to do is I'm going to rationalize the denominator. So let's multiply the top and bottom by the square root of 2. So on top we have 2 square root of 2. This becomes 2 times 2, which is 4. Square root of 4 is 2. So we have this at the moment. And then 2 divided by 2 is 1. So our final answer for this problem is the square root of 2 raised to the square root of 2. That's as far as we could simplify it. So that's basically it for this video. Now you know how to simplify algebraic expressions that contain irrational exponents.